We are going to start section 7.6 today. We'll see how far we get. We might have to wrap it up tomorrow. We are going to add, subtract, multiply, and divide functions. We are also going to find the composite of two functions. Lots to do, which is why we might have to wrap it up tomorrow. To start, we are going to review some functions. So let f of x equal 3x plus 4. So f of x is just the name. So f would be considered the name. It's saying we're using the variable x. If you want to write yourself a couple of notes about that, you could. So this is the name of the function. This is the variable used. It's kind of like y equals instead of an f of x. We used to see a y there. Okay. We're just naming it a little bit differently. We are told to find f of 2. So notice instead of an x, they put a 2 there. So in the function, instead of an x, what do you think we want to plug in? A 2. So f of 2 equals 3 times 2 plus 4. 3 times 2 is 6 plus 4 is 10. So f of 2 is equal to 10. Notice that the f parentheses 2 side didn't change. I didn't move it. I didn't do anything with it. What f of 2 means is find out what it equals when x equals 2. Okay, so we just plug in 2 for the x, figure out what it simplifies to be. I think getting students to understand that concept is one of the biggest roadblocks for these. So on the next one, now we're naming our function g. We are still using the variable x. We've got 2x squared minus 3x plus 1. And we are finding g of negative 3. So what am I going to do? Good. Plug the negative 3 into the x. So g of negative 3 equals 2 times negative 3 squared minus 3 times negative 3 plus 1. When we do this, we have to be careful because that exponent of 2 belongs to what? The negative 3 only. And if we're doing order of operations, what do I do first? Multiply or exponent?
Exponent.
Exponent first. So this becomes 2 times what? 9. Okay, we've got negative 3 times negative 3. That becomes
9.
Positive 9. So it changes to a plus sign and then plus 1 on the end. Next we multiply. 2 times 9 is 18 plus 9 plus 1. Now it's all addition. We get 28. So g of negative 3 is equal to 28. Okay, down at the bottom it says these functions, should have an S on function, these functions are written in f of x notation. Two functions can be added, subtracted, multiplied, or divided. Those are all things we can do with functions. All right. I will write these out a little bit bigger next to or below where they have it written. So for addition, we have f plus g of x. So that says that we are going to be adding two functions together, adding f and g. So that is the same as taking the function f of x and adding it to the function g of x. So the front part tells us what we're doing. We're adding f and g. The right side shows us how we do that. We take one whole function and add it to another whole function. It's very similar with multiplication and subtraction and division. They just have it written differently. So the left side shows us f times g of x. The right side says that means we're taking f of x and multiplying it by g of x. Same idea for subtraction. The left says f minus g, still using the variable x. So we take that first function, which happens to be f of x in this case, minus g of x. Much like with anything involving addition and multiplication, those are commutative, which means that we can add or multiply in any order. With subtraction and division, that is not necessarily the case. We have to be careful about what order we subtract and we divide. So here we have f over g of x, and that is equal to f of x divided by g of x. Okay, this will make a little bit more sense when we actually have functions to plug in instead of just the f's and g's. But this is how we define our function operations. All right, so for our examples at the top, we've got our functions defined. F of x is equal to 3x plus 8. G of x is equal to 2x minus 12. Is that printed on your paper for you? Wonderful. Okay, so we need to find f plus g of x. So we are doing what operation? Addition. So you should have just put in your notes that this is the same as taking f of x plus g of x. So I'm going to, instead of an f of x here, put the function for f of x. What is it? 3x plus 8. 3x plus 8, and then we've got that plus sign in the middle. What's g of x? 2x minus 12. Okay, what should we do with this? My questions would be plug in what and distribute what? Add what? Okay. Okay, so we can now combine like terms. If we're adding these together, if you saw this in Algebra 1, I hope that your instinct would be to combine like terms, and that is exactly what you should do. 3x plus 2x would give me 5x. Positive 8 plus a negative 12 is a negative 4. So that is our answer. That is what f plus g of x would equal. We were not given a value for x, so we can't plug something into x. We don't know what x itself is. And based on what they've given us, we have no way of finding it. Okay, next we are going to find f of x minus g of x. Now, on ones with subtraction, I like to put big parentheses with the subtraction sign in the middle. What do you think goes in the first set of these parentheses? Why? Good. They put f of x first. F of x is 3x plus 8, so that's what I'm going to put first. Minus sign in the middle. What goes in the back? 2x minus 12. Now, on the first problem, I didn't use the parentheses because it was addition. We could have used them. but it wouldn't have changed anything that we did. Why do you think I put the parentheses on the second one? Lanaya?
Because it would have seemed like you were just trying to 8 minus 2.
I think you're on the right track. That negative sign, that minus sign, it doesn't just belong to the 2x. What else are we subtracting? The minus 12. We are subtracting that whole thing. So what do you think we need to do with this minus sign? Distribute it. Okay, so the front set of parentheses is not changing.
Oh, -2.
Good. So we end up with 3x plus 8 minus 2x plus 12. We have to give the minus sign to everything in that back function. Well, we can do it with addition, but is distributing a positive one going to change any signs? No. So that's why we don't worry about doing it with addition. The signs aren't changing, but subtraction changes the signs in the back. So now when we combine our like terms, we have 1x plus what? 20. If you just put x plus 20, that's fine. If you like to write the 1 out in front, that's also fine. Questions about letter B? Okay, on letter C, what operation are we doing? Multiplication. Okay, so they wrote it f times g of x. We know that that's the same as f of x times g of x. Again, with multiplication, I would use parentheses. Times g of x. If you want to put the dot in the middle, you can, but we don't usually do that when we've got parentheses right next to each other. What's going in my first set of parentheses? 3x plus 8. And my back set? 2x minus 12. What do you think we need to do? Distribute, but not just single distribute, but double distribute. Jacob?
So the x in the back,
Mm-hmm.
it says like find f times g, that means that they're both f of x and g of x.
Right,
Not
yes.
g.
That's a good point. So when it says f times g of x, it means both of those functions should be in terms of x. That x is the variable used for both of those functions. Okay, it's a good question. So we said that in order to calculate this or figure it out, we have to double distribute. So 3x times 2x. Close?
6x squared.
6x squared. 3x times negative 12.
Negative 36.
8 times 2x.
16x.
Positive 16x. And 8 times negative 12. Negative 96. What can we do here? Okay, we can combine those terms in the middle. So we end up with 6x squared minus 20x minus 96. Good. So really, looking at this example, none of this is new operations. These are all things that you've done before. You have had to add polynomials together. You've had to subtract polynomials. You've had to multiply them. It's just that the directions are written in a different way. All right, on our second set of examples, did they fill in the functions for you again? You don't know f of x and g of x?
Oh, yeah.
Okay. So we've got f of x equals x squared minus 1. G of x equals x plus 1. What operation are we doing on letter A? Multiplication. Again, they wrote it a little bit differently, but we're going to treat it the same way. We're taking the f function times the g function. Usually we would like to see it with it written in the x in the back so that we know that they know that our variable is an x. Once again, I would use parentheses when we're multiplying these together. Helps us remember to double distribute. What should go in my front parentheses? X squared minus 1. And in the back? X plus 1. Once again, we double distribute. X squared times x. X cubed, good. Add the exponents. X squared times 1 plus 1x squared. Negative 1 times x is a minus x, and negative 1 times 1 is a negative 1. Can we combine like terms? No, because there are not any like terms. So that is it. That's our answer. All right, letter B for number 2 is probably one of the trickier problems. What type of problem is it? A division problem. So I would recommend treating these division problems with a big fraction bar. Again, we would put f of x on the top since they put f on top, and g of x on the bottom since they put g on the bottom. So on my numerator, I'm putting x squared minus 1, and in the denominator, x plus 1. Now, when we're doing division, there are a couple different ways we can go about it. One way would be to use synthetic division. We could go back to that. This one, I would recommend factoring your numerator and seeing if we can get anything to cancel out. What will the numerator factor into? Good. X plus 1 and x minus 1. We have the difference between two perfect squares. X plus 1, x minus 1. And what do you think is going to cancel out? The x plus 1s. If we put those binomials in parentheses, this binomial matches exactly on the top and the bottom. That means they reduce to a 1. So what are we left with? X minus 1. We could have gotten the same answer if we'd used synthetic, just to show you what that would look like if you're not great with your factoring. Okay, if we're taking x squared minus 1 divided by x plus 1. So if we write it out with a division sign instead of as a fraction. Okay, first one's from the top, second one's from the bottom. What number should I use in my little box? A negative 1. We use the opposite sign from the back. And then what about my numbers across the top? 1. What should I put in the middle? No. No. 0. We need a 0 placeholder. Okay, we need that 0 placeholder for the x term that's not there. We drop the first one. We multiply 1 times negative 1 and we get negative 1. We add down that column. We get negative 1. We multiply. And we add again. 0. Okay, we got a remainder of 0. We go back and plug in our variable. So we start 1 degree less than the original. So instead of x squared, we start with x and then a minus 1. So either way, we get the same answer. 2 different ways to do that problem. Okay, so we've got f of x is x squared plus 1. G of x is x to the 4th minus 1. Letter A is asking us to do what operation? Multiplication. So we use our parentheses. We put in our 2 functions. X squared plus 1. X to the 4th minus 1. We have to double distribute. X squared times x to the 4th. X to the what power? When we multiply the same base, we add the exponents. We should get x to the 6th. X squared times negative 1. Negative x squared. 1 times x to the 4th. X to the 4th. And 1 times negative 1. Negative 1. Can we combine any like terms? No, but what do you think I'm going to tell you to do? Put it in order. So we would have x to the 6th first, then what?
X to the fourth.
The positive x to the 4th, then negative x squared, then minus 1. So go ahead and put it in standard form. All right, on letter B, what operation do we have? Division. We'll go ahead and do the synthetic division way, since that's what some people said they preferred. We'll see if it works on this one. I'm not sure with that power.
I don't know how to do that. You might have to do that.
Let's see. So we're taking x squared plus 1, and we are dividing it by x to the 4th minus 1. I'm not entirely sure about synthetic on this one. I would have to work it out and see. I know for sure, though, that if we do it factoring, that we'd be able to get there. Is x squared plus 1 going to factor? No. But x to the 4th minus 1 will. It's still a difference between two perfect squares. So it factors into x squared plus 1 and x squared minus 1. We did see that in chapter 6. What's going to cancel out here?
X squared plus 1.
The x squared plus 1s cancel out. So what's left in my numerator?
X squared minus 1.
In my numerator.
0.
Not a 0.
1.
A 1. Okay, this reduces to 1 over 1. So I have 1 over x squared minus 1. Okay, so that's why I'm not entirely sure what synthetic would look like on that one, but I knew factoring was going to work out for us. So we will pick up with the 7.6 notes at composition tomorrow.